Section 6.1 on rational exponents. Remember, rational means is short for ratio. The word ratio is in here, ratio, and that means a comparison of two things, which can be written as a fraction. So whenever you see rational, that word, you should think fractions. And we've already talked about negative exponents, which means to take the reciprocal. We've talked about exponents with 0, what's anything to the 0 power equal to? 1, right? Simplifies to 1. All of it simplifies to 1. So what if there's a fraction in the exponent, like 3/4, raised to the 3/4 power, etc. So we're going to do a table here, and we'll list some expressions in exponent form, and then we'll convert it to radical form, and you have to be able to go back and forth, because what the fractional exponent means is it means it's a radical, and then we have to be able to simplify them or evaluate them simplified. So for example, when you know what the square root of 9 is, what? Square root of 9 simplified is 3. So you've seen this before, but you might not be as familiar as writing it like this: 9 to the 1/2 power. And all those are equivalent. 9 to the 1/2 power means the square root of 9, and of course that is 3. I'm going to do some more examples, and you'll see the pattern. 16 raised to the 3/2 power is the same as 16 cubed square root. Okay, so you can do this when you evaluate this. You can do it in either order. You can take the square root of 16 first and then cube it, or you can cube it and take the square root. There's one way that's easier. You want to get the number smaller, so the square root of 16 is 4, and then cube it. That's definitely will make your life easier, and 4 cubed is 64. So simplified, it's 64. Let me do some more examples. 1 raised to the 7/8 power is basically 1 raised to the 7th power and the 8th root. So you can see the fraction, the numerator is the power and the denominator is the root. So let me write that up here. When you see a fraction, the meaning is that the numerator is the power. The numerator is the power, and this power, and this denominator is the root that you're taking. So even in this basic example, there's invisible numbers here, right? Because this is 9 to the 1 power. And square root, we don't write the 2 there, but whenever you take the square root, there is a 2 there. And this, so 9 raised to the 1 power square root is 3. So what would this evaluate to? 1 to the 7th power 8th root is equal to, well, 1 to the 7th power is 1, and the 8th root of 1 is 1, yeah. Let's do 81 raised to the 3/4 power. So that's 81 cubed 4th root. Okay, if you do 81 cubed, here's a good example where you're going to get a really big number, and that's obnoxious. So do the 4th root first. What number, when you multiply it by itself 4 times, gives you 81? Just, yeah. We could try things. 2, well, 2 times 2 is 4, times 2 is 8, times 2 is, yeah, let's try 3, probably 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, yeah. So it's 3. It's 3, right? So take the 4th root first, and then cube it, and you get 3 cubed is? Yep, good. Okay, and now let's just, for review's sake, let's just throw one in there that's a negative exponent. So 9 to the negative 1/2 power. So you know that when you have a negative power, that means you take the reciprocal, and that means you can make the exponent positive. So it's 1 over 9 to the 1/2 power, and we know 9 to the 1/2 power is 3 from before, so it's just 1/3. So that's just converting. So one of the skills from today is just being able to go back and forth and know what a fractional exponent means. Now let's look at some examples of equations. Those were expressions. These are equations that we want to solve. So let's say I have x to the 2/3 power equals 25. Okay, so that's an equation, right? And I want to solve for x, and it looks really different. And so the way you can solve these is by raising this, because you know the properties of exponents now. I want to basically get rid of this raised to the 2/3. So what could I multiply 2/3 by so that it becomes 1, and that basically I don't see it anymore? What's that? Yeah, very good, the reciprocal. So if I just raise this, you're allowed to do this, raise both sides to the 3/2 power. This will become x to the 1 power, because whenever you take a fraction and you multiply with the reciprocal, that's 6 over 6, right? You multiply straight across. It's just x to the 1 power, which is the same as x. And now we know how to evaluate this. This would be 25 cubed and square root. So that gives us just x equals, take the square root first because that's easier, 5 cubed or 125. And let's do a couple more equations that you can solve different ways. Let's try example 2 is going to be, I'll start example 2 on a new page. Example 2. Let's try x cubed equals 64. X cubed equals 64. So what could you raise this to? The 1/3 power, right? Or you just take the cube root, but raising to the 1/3 power is the same thing. So 64, the cube root basically of 64, which is just 4. Right? And last example where we have to be a little bit careful, x plus 5, let's make an expression to the 4th power equals 16. So we can raise each side to the what power? To get rid of a 4, what's the reciprocal? Yeah, raise it to the 1/4 power, which is really taking the 4th root. So you would say x plus 5 equals the 4th root of 16. You have to be a little bit careful here, because whenever you have an even power, could be more than one answer possible. So you get x plus 5, the 4th root of 16 is what?
2.
That's one answer. Yeah, it's plus or minus 2, so be careful with even powers, because you need plus or minus. Because let's think about it. 2 to the 4th power, let's check. 2 times 2 times 2 times 2, yeah, that's 16. Negative 2, does that work? Negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is 16, it works. So to get this question right, you need both answers, so let's just finish the problem. Subtract 5 from each side to get rid of this. So it's negative 5 plus or minus 2, and since it's easy to simplify, you should. So it's negative 5 plus 2, which is negative 3, or negative 5 minus 2, which is negative 7, and you can always go back and double check, plug it into the original equation, and make sure that it works.